All right, we're going to look a little more closely at the connection between graphs and equations of quadratics, specifically determining zeros. Remember zeros, these are synonyms for x-intercepts. And we added that word roots to our lexicon the other day. So roots, zeros, x-intercepts, we get these all from the same place in the graph. And if I look at this first graph, I can see pretty clearly here's one and here's another one. This one happens at x equals 1. This one happens at x equals 5. If I were to go look in the table, that tells me that when I get to where x equals 1, y is 0. And when I see x equals 5, there's going to be another 0. We want to be careful that we're not looking for where x is 0, because remember that is our y-intercept. So the 0 that I find over here, I'm not interested if our focus is roots, zeros, x-intercepts, right? We're looking for the y is 0, which happens in these two places. Okay. Well, I can use that information to write an equation. I already have standard form, which is ax squared plus bx plus c. And I already have vertex form, which is a times x minus h squared plus k. Well, now we're going to use the roots to write in what's called factored form. Right? This is our new one. A times x minus root 1 and x minus root 2. This a value, it's the same every single time. A is always A, right? And we get A by looking at the vertical stretch. So if I come to my vertex and I move over 1, I'm going to count how far up do we have to go to get to the next point. That tells me my A value, in this case, is 2. And keep x minus. My first root that I came across over here was 1. X minus the second root was 5. This is factored form of this graph. If I type that into my calculator, I'm going to get this graph. I'll be able to verify everything from the table. Okay. Well, let's grab a second one. Okay. Already, because this one is facing downwards, it's opening down, I know that my A value is negative. And if we move to the side and count down, in this case, it's 2. So A equals negative 2. And if I look at my x-axis, 1, 2, negative 3. And over here, positive 1. So I grab my formula. Y equals A, x minus root 1, x minus root 2. Y equals my A value, negative 2, x minus, and careful here, that's why we write this down the way that I've been doing it, because when I put in a negative 3, we're going to need to clean that up later. Okay. I don't want to leave that minus a negative or subtracting a negative, so we're going to rewrite y equals negative 2 times x plus 3 x minus 1. Okay, if we go check that, y equals -2 times x plus 3 times x minus 1. Oops. I'm going to put it back in my standard window because I had it open weird earlier. We'll watch our graph. It goes right through the same places. If I kind of estimate how high it is, it looks like it's at about 7 or 8 in my calculator. When I come up here, 8, 9, 10, so it looks about the same. We're going to verify with the table. When I go through my table, just like before, I'm looking for where y is 0. So if we screw this up a little bit so it's easier to see. There's one at -3, 0, and 1, 0. If I look at 0, 6, my y-intercept, I can check that on here, 0, 6. So I have 3 points in common, so I know that I have the correct equation for this parabola.